Okay, this is section 8.2, the reciprocal function family. So for A, B, and C, I would like you to try this on your own. I think this is something you could do. So first try it on your own, and then we'll do this together. And remember, you can always find this on the Sycamore documents and print it yourself, or just be working on it on another piece of paper. But you will still have to submit evidence that you watched the video by showing your notes to me. Okay, so your next class party is a dance party. It is going to cost 250 lira to rent a hall. Your homeroom teacher isn't sure how many people are going, so we want to know, is there an equation that can model the cost for each student no matter how many students come? So the students are paying for this hall, so if 10 come, 15 come, 20 come, we want to know how many or how much money they would each pay. So a nice way to do this if you're not sure is just to do some examples. So let's say 10 people come, how much would each pay? Well, mathematically, we would just do 250 divided by 10, and that would give us 25, so each person would pay 25 lira. So that mathematics that we did of division is what we'll do for our equation. So because we don't know how many students are coming, that's why we did divided by x, and y would be how much each person pays. So once we have the equation, which we do, now we will graph it. So it doesn't make sense to put 0 in because we won't have 0 people going and we can't divide by 0. So if I put 1 in, that's already 250. So let's just choose some numbers that might be nicer, like 5. That's a 5, by the way. 5, 10, 25, 50, and 80, just to kind of space things out. Because if we just choose like 1, 2, 3, that's only going to give us a very small amount. And as you can see, I gave us big numbers. So if I plug in 5, that means each person is paying 50 lira, as we calculated ourselves. 10, 25, if 25 people come, each person paying 10 lira, 55, 80, 3.125. Just plugging those into the function and finding the y's for those x's. So if we graph, so let's see, each one of these is 2, I think. Nope. Well, halfway is going to be 5. So if I go in between 0 and 10, so that would be 5, 50. Then we have 10, 25, 25, 10, 55, and 80, 3.125. So this should be looking pretty similar to what we did last section with inverse variation, which reciprocal functions kind of fall in that. So a reciprocal function, as you can see, never crosses the x and y axis. Because it makes sense that we can't divide by 0. We also can't divide anything to get 0. And it doesn't make sense for our situation to not have any students go or for them to pay $0. If I were to graph the negatives, I would also have a graph in quadrant 3, and this is called origin symmetry. So if I have a point x, y, so let's say I had the point 1, 2, it would be reflected to -1, -2. Let's say for some reason after reflections and such we have -x, y, so this time we have it in quadrant 2, so origin symmetry would be in quadrant 4, which would be x, -y. So those are just examples of how origin symmetry works. So if you notice, the signs change. So if I have positive x and y, it becomes negative x and y, negative x, y. The signs change for the symmetry. And lastly, the asymptotes, which relates to what they never cross, remember. So the lines of the asymptotes would be x equals 0 and y equals 0, just the x and y axis. So that's reciprocal function family. Basically, it just requires some division with x. We will get into transformation soon. So try this one on your own. What is the graph of y equals 8 over x? Identify the x and y intercepts and the asymptotes. So again, pick x values that make sense, and you're going to identify the domain and range. So I would suggest pausing the video, and then I will show you the answer. Okay, so here's the graph with the table. So I gave you the positives and the negatives, but you could just graph one. Like you could just graph quadrant 1 and then use origin symmetry to find quadrant 3. There are no x and y intercepts, obviously, because it doesn't cross the x and y axis. The asymptotes, x equals 0, y equals 0. Domain, everything except x equals 0, which that makes sense because it's never crossing it. And then range as well, everything except y equals 0. So let's move on. Transformation time. Every single function, we talk about transformations if you haven't noticed. But hopefully by now you get the gist of them, because in graphing, that's really what we use, because it's much easier than trying to plug in points because you're not sure where the main stuff goes on always and how much something is stretched or compressed. So that's why using transformations is nice. So general form here, y equals a over x minus h plus k. However, in this case, x can't be h because that would be dividing by 0, but that's just an extra thing. Okay, so what I want you to do is to graph these three functions below, and you're just trying to see what happens. Okay. So go ahead and pause the video and graph those, and I will show you what those graphs look like. Mine, as I look at it, is quite messy, so I hope that you are not too offended by it. Here it is. So the black one is this, and this. That's just the standard reciprocal function. The red one is the 6 over x, and then the pink one is the 0.25 over x. So what we want to do is just make observations of what's happening here. So if a, as in the number above x in the numerator, is bigger than 1, it's a stretch and it goes farther from the origin or from the axes, as you can see with the 6. If I did 10, if I did 100, like I'm just going to get really farther and farther from the origin. If the number is between 0 and 1, such as the pink one, you can see it's getting close to the origin, so it's moving closer to the axes. So when you graph these, you can be kind of precise, but you also can just have a general idea of the way that the stretch and compress works. Okay, next, we're adding in some addition and subtraction with it. So still graphing in that quadrant or in that coordinate plane, can you now graph negative 6 over x, 6 over x plus 2, and 1 over x minus 2. So you should pause the video and graph those. Or I even suggest just looking at Desmos. So you should, I hope, even know what would happen to the graph. So if I was looking at the red one, which is 6 over x, and I added in some negative, I would hope you would remember that that would be an x-axis reflection. So I would take that graph 6 over x and just reflect it over the x-axis. Let's see, now we have adding or subtracting in the bottom. So if we're adding 2 to 6 over x, the graph would move left 2. This is our horizontal translation. Remember, horizontal translation is always opposite to our intuition. So if it's a plus h, we're going left. If it's a minus h, we're going right. And the last one, we have a minus 2 on the outside, so that is the vertical translation. So that 1 over x graph would be shifted down 2. And so that means, yep, that one's down 2. So the major question, and that is really helpful in graphing, is figuring out how do transformations affect the asymptotes. So I want you to think about which transformations would that be. So the ones that would affect the asymptotes would be the translations. So normally we have the asymptotes as y equals 0 and x equals 0, right? But let's say we had a shift right 2 down 3. Well, that means that at 2, that vertical one would go over, and if I had down 3, that means my horizontal asymptote would move. So now my graph would more look something like this. So the asymptotes are really good to identify where they are, because then that gives you a better guide to your graph. Notice in reflections it doesn't matter because I'm just flipping the graph, but like the asymptotes still stay the same. So if I had the equation y equals 2 over x minus 3 plus 4, I want you to tell me what would be the equations of the asymptotes. So pause the video so that you can answer that question. Again, what would be the equations of the asymptotes? So the equations would be x equals 3 and y equals 4, because we have a shift up 4. So normally I have the asymptote at y equals 0, but it's being shifted up 4, and then normally I have the asymptote at x equals 0, but now it's been moved right 3, so at x equals 3 would be the vertical asymptote. So this is the vertical asymptote and the horizontal asymptote. So we're moving both in this case because we have both a vertical and a horizontal translation. So the next part is graphing with these transformations. Okay, so there's a few things that you could do. Either you can just start with the basic graph, which would be the parent function, which would be 1 over x, and then move things. Or past students have sometimes instantly just graphed the new asymptotes and then thought of the intersection of the asymptotes as the new origin. Whatever works for you. Yeah, my preference is just to move the graph. So if I take 1 over x and I graph that, so if I just pick some points. So if I plug in half, I get 2. If I plug in 1, I get 1, and then 0.5. So normally my asymptotes are x equals 0 and y equals 0. I'm moving right 1 and down 2. So that means my new asymptotes will be at x equals -1 and y equals -2. So this is where my graph will be focusing. Okay, so if I have the point 0.52, but it's been shifted left 1 and down 2. And then I have the 0.11, but again, left and down 2. And then 2.5, left 1, down 2. So here's my graph. And instead of